So this video is going to help us work on the first question, and the question that we're dealing with is, was there a statistically significant difference between the WebCT group and the control group, and it's instructing us to do an independent samples t-test. So what we're going to need to do is go into Excel, find the data, take a look at that, and then we're going to basically put it into SPSS, and I'll just show you how to do that. And then from there, we're going to actually run the t-test and interpret the results in the printout. So here is the Excel data set. And you'll notice that there are 6 columns of data. The first column is ID. That's just the subject numbers. You can disregard that. We're not going to use that in the analyses. It's just helpful for reference. Group, and then the group variable is either a 1 or a 2, depending on what the assignment is. If it's an intervention group, it's a 1. If it's the control group, it's a 2. Biological sex, 1 or 2. And I think in this one, males were a 1, I think. I have to go back up and look here. What did I put that down? Yeah, males were a 1, and females were a 2. And then we have the global assessment of functioning on the pre-test, and then on the post-test, and then the Beck depression inventory to outcome. Now, the easiest thing to do here is to just copy and paste these data. And you should start by putting in the ID, and this is a string variable, so it's a little bit different than the other variables. And by string, we just mean it's text. It's not numeric. You can't do any analyses on it. So I'm going to go ahead and copy that, and then I just take my SPSS file, and I'm going to paste the data in, and you'll notice that right away it creates variable 1. Okay, and it says string measure nominal. So it recognizes that this is not numeric data because it sees the S in there. Now I can change the name of this just by double clicking on the name, and I'm going to put in here ID. Okay, and it's giving it a maximum width of 4. It's telling me that this is non-numeric data, string data. And then the rest of this we can pretty much ignore. So we've got one variable in. And then what I'm going to do is I'm going to take the other data, and I'll just copy it in. So now I've copied it. I'm going to go back to data view and just go right here and paste, and it automatically creates those variables. And then what I want to do is basically duplicate these columns in terms of the labels. So variable 2 I'm going to call group. It used to be in SPSS, it would automatically get rid of the label that was in there, but now I think you have to actually delete it. So bio sex, and then GAF pre. And again, the reason I didn't paste everything at once is if I did that, it would I think identify these numeric variables as string variables, which I don't want. These are actually variables that are numbers. So you can see now that my variable names match up with what's on SPSS, and at this point I can get rid of my Excel file. I can get rid of that. And so then I just look at my variable definitions. And group, that was a 1 or a 2. There are no fractional amounts, so I'm going to say 0 decimals there just to make the sheet look a little nicer, easier to interpret. Biological sex had no decimals, so I'll say 0 there. In fact, all of these are without decimals, so I don't think I need decimals on any of them. These are whole numbers. What I do need to do, though, is to define what those values mean in the worksheet. So group, if I go under values here and click on the cell for group, I'm going to say a value of 1 is equal to web CBT treatment. and then I'm going to add it. Okay, and a value of 2 is the control group. I'm going to add that and click OK. Biological sex, I'm going to do the same thing. Say a value of 1 is equal to males. I'm going to add that. Value of 2 is equal to females. I'm going to add that. So that's good. Now, these other variables here, these are all continuous variables, scores or ratings that are provided. So I don't need to provide labels for categories. We can just leave these as they are. The other options that SPSS gives us, which we're not going to go into, is you can actually enter into SPSS a value so that SPSS will recognize when data are missing, which is important because a lot of times you may not get data or a subject might skip over a question, not hit a question, and so forth. And if you just leave the cell blank in SPSS, it looks like maybe the data was not entered to begin with. It's out there, it just wasn't entered. By entering in a code for missing data, so like if I clicked on, say, GAF pre, and I entered in a code of 99, okay, that becomes a placeholder. So if a 99 appears in a cell under this variable, what that means is we don't have that data. It's not that we did not enter it, it's that that data was never entered in by the subject. And so that's the code I would use to tell SPSS that. And what SPSS will do is then skip over that cell. It does not calculate the 99 into any analyses. So that's kind of a neat little feature. The rest of these here are basically just telling SPSS how to align the data, what scale is being used in the data. If we had more time, I'd go into that a little bit, but it's not important that we do that now. So let's go back to data view, because now I have what looks like a real good SPSS worksheet to go with. And you can see I can spread these columns out a little bit more. But it looks just like our Excel sheet pretty much. Just now we're in SPSS, and that gives us more functionality for statistical analysis. Okay. So now that we have the data in the sheet, let's go back to the question. Was there a statistically significant difference between the Web CBT group and the control group? Run an independent samples t-test. So to do that, I'm going to go in here and actually think what I need to do. I'm looking for a menu. I was thinking that I guess the menu is outside of the screen here on the screen capture, which I will fix in the next video. But what I'd like you to do is, as you look at SPSS, hit Analyze, and you're only going to see part of the drop-down menu there. But if you click on Analyze on the main menu, and then you click Compare Means, and you can just see at the top of the screen there part of the little drop-down menu from there. But go to Independent Samples t-test, okay, and click on that. So up comes Independent Samples t-test, and this is the screen that you really want to see. And you'll see a dialog box here, and it'll say Test Variables and Grouping Variables. Well, the grouping variable is essentially the variable that tells SPSS, okay, what kind of groups do you have here? And we already know that, right? One is a treatment group, one is a control group. The treatment group is the Web CBT group. So I'm going to take group, and I'm going to drag it to the grouping variable, which I thought would work but didn't. But okay, then I'm just going to click the arrow and move it over. And you'll see this kind of strange notation. It says group and then question mark, question mark. And basically what SPSS is saying is, I don't really know what the values are that identify the groups. Can you please tell me? So I go to Define Groups, and the first group is the Web CBT group, and we already know that we coded that as a 1. So I'm going to put a 1 here. And then the second group, okay, is the control group, and we know that we coded the control group as a 2, so I'm going to put a 2 here. Now, just because the 1 and the 2 right there in the entry boxes match group 1, group 2, doesn't mean it'll always be that way. If you have a big a big file, that has multiple groups and so forth, the values in here may not be 1 and 2. So I'll say continue. So now you see the question marks are replaced. So we've set up our groups that are going to be compared, and we're interested in the question of whether or not there was a statistically significant difference between the web CBT group and the control group, and we're going to be interested in the scores on the BDI2, okay, because that's our primary outcome measure. I'm going to put that in here. And so now we have our test variable. This is what we're looking for differences in mean scores on. And we have our grouping variables, which tells us about the web CBT group and the control group. And I can go to options, but really there aren't many options for this t-test. There's just a confidence interval percentage and then how to handle missing values. We know that we don't have missing values, so that's not an issue. And so that's it. So then we're just going to go ahead and run the t-test. So we click OK, and then up it comes. And let me move it up here so it's a little easier to see. Okay. Okay, so relatively simple printout. Right here we see the test variable BDI2. That's what we're looking for mean differences in. Here's our two groups, the web CBT treatment group and the control group. We define these terms when we initially put the data in. Each group has 50 subjects, so the N is 50. And the mean for these two groups on the BDI2 is 28.84 for the web group and 30.36. So again, keeping in mind how the BDI is scored, lower scores mean less depression. So the scores for the web CBT group are in fact lower at the end of treatment than the scores for the control group, the mean scores for the control group. Now, is that a statistically significant difference? We can't tell just by looking at the difference between the means. What we have to take into account here is the variation within groups, right, which is fairly large, 12 points and 13 points. And then that ultimately gets all distilled once we take into account the number of subjects and the standard deviation into what's called the standard error of the mean, which is going to be pooled when we do the t-test. Okay, so we'll talk a little bit more about that probably in class. Okay, so remember our assumptions for t-test. One of the assumptions is homogeneity of variance. So here's the Levene's test for equality of variances. Again, remember, we're looking here for a non-significant result because we would like to say that there's no evidence that the variances are different between these two groups. And in fact, when Levene's test is run, the F ratio, which is the test statistic, is only 0.03. The p-value or significance level is 0.855, nowhere close to 0.05. And so that's a non-significant result. So our conclusion is that there is no evidence that the variances are different between the web CBT treatment group and the control group. Therefore, we are going to assume equal variances. So when we interpret the t-test, we're going to look across this top row. Okay, we're going to ignore this bottom row. Don't need to worry about that. They usually yield pretty much the same results anyway. But we're going to look across the top row. You see a gray dividing line right here. That tells you that the actual results for the t-test you're interested in come next. And here's the t ratio, or the t statistic. And that value is negative 0.567. Okay. Now, the fact that it's negative tells you that the mean for the web CBT group was less than the mean for the control group. So the t-value is going to be negative. But it's not very big, right? It's within one standard error of the mean. If we look up here, that means that it's not a very big difference compared to the variability we see overall in the data set. There are 98 degrees of freedom, and the significance level is not 0.05, but it's 0.57. So to interpret these three, okay, the degrees of freedom pretty much tells us roughly how many subjects were involved in the entire test, how many participants there were. It's not exactly the same because the formula is the overall n minus 2. And so you end up with 50 plus 50 is 100. Our degrees of freedom then comes out to be 98. The t-test result is negative 0.567. The significance of that is 0.57, and what that means is the probability that we would observe this result right here by chance or measurement error, in other words, randomness could account for it in the data, there's about a 57% chance that that's the case. That's how you can interpret that. Well, if this difference is so small that the difference could be accounted for by essentially random factors 57% of the time, then we really don't have much of a difference. This is not good news if you're a researcher. Let's say that you're a cognitive behavior therapy researcher and you're absolutely convinced that this web program is going to help people, but any decrease in scores that you see in the mean had a 57% chance of being due to something other than the treatment. That's not good news. So, so right now we have a non-significant test and test result, and so we would fail to reject the null hypothesis in this case. Fail to reject the null hypothesis, and we would then have to write that up. So we're going to write that result up in the following way. Let's see. Let's see if I can run just a note here real quick. Okay, so how would you write that up? You would say something like this. An independent samples t-test comparing the web CBT group to the control group was not statistically significant. Okay? Now you have to enter in the actual result. And so in APA format, we'd say T, because that's the type of test. I would italicize that, but I don't have that functioning in this particular program, so but I would italicize the T. Degrees of freedom, if you recall from the, there is 98, and then equals negative 0.567. We're just going to carry that out to the hundredths. This is negative 0.57. Okay. And then the probability of that event occurring, of that result, is 0.572. Okay. So kind of coincidental that both the t statistic and the probability value had the same value of 0.57. Now, when you get a non-significant result, you don't have to put the p-value in. In fact, what I do, which is acceptable and journals accept and so forth, is I just get rid of the p-value and just say NS. Okay, not significant. Okay, so you don't really need to know the probability value if you fail to reject the null hypothesis to begin with. Anyways, there's your sentence for the actual test result, and that's what you put into your result section. It's very concise. It's very tight. Doesn't elaborate much on why you found what you found. That's something you'll wait for the discussion section. But and now we would move on to the next test to do in the assignment.